Good evening. Welcome to the 79th edition of FAYA Port 80 in association with NASCOM. Today we have Samuel. He's the co-founder of MistEO for leading the session in AgriOs. Before that, I want you guys to know about Port 80. The idea of Port 80 is free knowledge sharing. Held on Trivandrum, Kochi and Kozhikode in first, second and third Wednesday of each month. Next we have Tech Bites. For that I invite Lavanya.
Good evening all. Welcome to Tech Bites. Let's have a look on the latest updates happened over the last month. First one, GitHub launched its mobile app. GitHub Mobile allows developers to work and communicate with their teams, and the app is available for iPhone, iPad and Android devices. A number of additional features were introduced, including semantic code navigation for all Ruby, Python and web repositories. Then second one, Google Stadia. On 19th November, Google launched a cloud service that truly lets you play big budget games without discs or downloads, consoles or gaming PCs. Google Stadia has been launched in countries including the US, the UK, Canada, France, Germany, etc. Google plans to launch the game in more countries by 2020. Google has not given any specific timeline for the game's launch in India. Then third one, standing wheelchair arrays. The Indian Institute of Technology, Madras, in collaboration with Phoenix Medical System, launched India's first indigenously designed standing wheelchair arrays. This enables a differently able person requiring a wheelchair to shift from sitting to standing position and vice versa, independently and in control. Arrays was designed and developed at the TTK Center for Rehabilitation Research and Device Development in IoT Madras under the guidance of Professor Sujata Srinivasan, who teaches in the Mechanical Engineering Department. So fourth one, Tesla Cybertruck. The truck will come in 3 versions with 250 miles, 300 miles and 500 miles of range. The truck can seat a total of 6 adults and the payload has a 3,500-pound capacity with 100 cubic feet of storage space. The is made of ultra hard 30x cold stainless steel. Then fifth one, 16-inch MacBook Pro with redesigned keyboard up to 80% better performance launched. The new refreshed MacBook Pro, which Apple is calling the world's best Pro notebook, offers the new components that are claimed to deliver up to 80% better performance and a new Magic Keyboard that should address long-standing complaints about the reliability of Apple's previous butterfly-style key switches. And Apple will offer this new notebook with Intel's 9th generation CPUs with 6 or 8 cores, up to 64 GB of RAM and 8 TB of storage. And these features are Apple's touch bar, a touch ID sensor, touch trackpad and Apple T2 security chip. That's all. Thank you.
Let's move on to the main session. Before that, I will introduce about Samuel. Samuel is the co-founder of MistEO. It is a computational sustainability company working in the domain of extreme weather. He is also the co-founder of SatSure, a satellite data analytic startup. And he also have a company named AgriOs. It is based in Trivandrum and Dubai. He is also a partner of Kerala Space Park, a government of Kerala initiative promoting space tech companies to work out of state. So let's main session. Samuel, please.
Thank you. Are you able to hear me? I think it is fine here, right? So good evening and thank you for inviting me to FAYA.80. This is my first time that I'm hearing about FAYA.80, but I hear that this event is very well attended. I mean, I hope that we will have more people coming in, so as they float in, we will have more conversations going on. So unlike other events, I don't know how the thing is structured. I would like to have more interaction going through the entire session. I'll try to keep it brief and sweet because I know that everybody wants to go home. So I'll make my pitch for what is called as AgriOs. AgriOs as a concept, where it began and now where we stand, and why do we require AgriOs in India and elsewhere. So thank you again for the kind introduction. We are a company called MistEO. It is very new. We only look at extreme weather events, and our main area of focus is insurance and extreme weather. So we look at more on the lines of blockchain, AI, GIS, and extreme weather all integrated into one stack. Pretty much it covers almost all the sectors: insurance, agriculture, marine, aviation. We are based out near Yamuna. Hopefully we will move to Technopark on the 7th floor pretty soon. We are just waiting for the space to open up in that area. I hear that space is premium here in Technopark. So when FAYA.at came to me, we had various going forth back and forth with FAYA.at. The idea was, what is it that I'm going to present to a team of very tech savvy people here in Technopark? I'll just give a disclaimer. I do not know even how to write a single line of code. So please don't ask me any technology related stuff as if you open this port, will be able to stream this data. I won't be able to tell you that because I don't know. But what I'm going to do is, what I do know is how these things work together. And my experience over the past 3 years in the industry, trying to get to a point where I'm able to do extreme weather on one part, I'm able to do agri-IoT on the other, I'm able to do satellite data analytics on the other. So when I'm talking, it's a journey that I've had for the past 3 years, and there is a lot of technology and there's a lot of concepts that I would be exploring, I'll be opening up, and then of course you can ask any questions, semi-tech related. I'll be able to answer that, and we will have an interactive session, as I said. So the idea that we wanted to talk today was about AgriOs. What is AgriOs? The title is self-explanatory. It is Agri Operating System. Now, the question then is asked is whether you are going to have one application that is spread across multiple devices, multiple domains, or you're going to have a stack of OSs, a stack of applications that runs, in a synchronous form to achieve a specific outcome. The answer is both. So you can have a single end-to-end OS platform that works right across the entire gamut of devices, applications, services on one part, and on the other part you could also have these applications that are completely, not linked to each other. However, using the service-oriented architecture approach or the system integration approach, you can actually marry them together. Now, before I move any further, I would like to know how many people here come with a farming background. I'm going to have a lot of conversation. Okay, there are two. How many of people here know anything about farming? No, that is done. You are done. You come from core agri background. But I guess yes. So I guess we can have a interesting conversation on how we can take this all out. So I'm going to avoid questions coming from you guys. Okay? Is that all right? Okay. Right. So let's just take a look at the state of play. The state of play, all these numbers that you see here are in billions of rupees. And this is in the past 2.5 years of what they call it, agri-related, GDP in the country. As you see, January always goes up and towards the middle of the year it comes down. But the general trend line is not that impressive. What we are seeing over the past 2 years is that the general contribution of agri-GDP in relation to the GDP in the country is actually nosediving. Now, this is a very important data point that you need to take up, because 50% of this country, 50% of India actually, or maybe even more, depend on agriculture. In relation to that contribution, their contribution is roughly what, if I'm not mistaken, that figure is 17%, 18%? It contributes about 18% of the GDP. The numbers on the right is even more alarming. In 2001, 60% of this country was in one form or the other linked to agriculture. Come 2050, that number is going to go down. So I'm going to assume that 18% will again take a nosedive. This is a serious problem. We have to feed what? By 2050, 2 billion people, and you're going to have 25% or maybe 12.5% of the workforce trying to feed that 2 billion people. This is where intervention comes in. This is where technology needs to come in. This is where automation comes in. The question of automation is, everybody says automation kills jobs. Automation and agritech also may kill jobs, and it's true to a large extent, because there is always a correction phase. Anytime you go and buy a Mahindra and Mahindra tractor, you're putting a lot of people out of jobs. But at the same time, you're also skilling them up for newer and newer challenges that they can take up. In fact, today there's a challenge actually set out by Mahindra and Mahindra. They are actually looking to nominate Agri Stars. So basically, this company is coming in and saying that, look, we want to nominate Agri Stars, and they will be given awards, and they will be given money, and they will go on, and they will skill them up, and they do whatever they want. Marketing ploy perhaps, but at the same time, it's got a very important point, is how you skill these people up. Now the question is, how many of you guys, the tech people, the services industry, want to step into this? This is a very key point that we need to ask. And in Kerala, I have not seen that much of a push. There are people in patches that work, but there is no consistent push towards getting into what is it called, the agri domain, from a technology perspective. Multiple IoT companies are there, multiple drone companies are there, multiple application development companies are there. In fact, if I'm not mistaken, there is one company here in Technopark, they only do rubber, in fact, as a matter of fact. They do a lot of work on the commodity space. They look at satellite images, and they look at the rubber, and they see if there is, if it is healthy or not, and then they predict the rubber prices, and from there, they hedge. They do all that kind of stuff. So the question is, you need to have a very baseline understanding of agriculture, so as you would. Understand the problem that the industry is facing in that perspective, and then work and employ technology to make what they call it incremental improvements over the coming few years. So by 2050, when the agriculture population drops down to about 12.5% of the population, we are able to feed 2 billion mouths. And that is the basic concept behind AgriOs. How do you employ technology in order to find technical solutions to administrative, manpower, efficiency problems? And I will now take you to the genesis. What is the genesis of AgriOs? Have you heard of something called the Agri Stack? Have you guys heard of the India Stack? No? Oh my God. Nobody knows what an India Stack is. What is an India? Do you know Agri Stack? Don't look at this and tell me the answer. Do you really know Agri Stack? Okay, what does it say? When did you Google this? A month ago. Okay. India Stack. Has anybody heard of the India Stack? All you guys are developers. You are all, I guess, working in fintech, UPI, Aadhaar, Jandhan. Nobody has heard of the India Stack? Wow. Please look up the India Stack. Next FAYA.at, please run a session on India Stack. Okay. So, in fact, the entire Agri Stack concept comes with three major emphases. The first emphasis of farmer stack, what's your good name, sir? As Tanveer said, the first stack is all about how you know your customer. In this case, it's a farmer. So you, sir, are a farmer. I'm assuming that you are. You have a property, and we need to know who you are. So you go on a Jandhan and you go on Aadhaar, and basically you know your customer, and basically you link this up. So this is called the JAM Trinity Stack, which is promoted by Government of India. So you have Jandhan, you have Aadhaar, and then you have your mobile. So the assumption is that The farmer will either have a Jandhan, either they will have an Aadhaar card, or they will definitely have a mobile. So you link these three things up to create what is called the farmer stack KYC. This is basic information about who he is, where he is, what is his name, how many years has he's been farming, how much property does he have, all that kind of questions. The second thing is a farm stack. Again, coming back to what Tanvir said, using remote sensing technology, GIS, bring together that entire thing into a spatial map where you put the location dimension of the farm size and basically estimate the farming needs and the potential income from that farm in the coming future. So this is the second pillar called the farm stack. The third one is called the crop stack. The crop stack is essentially, again, using ground truthing experiments. So basically going there on site, taking a look what is growing on one part, using remote sensing as a verification tool. How many drone companies? Anybody from any drone company here? No? Okay. Drone companies using drone data to verify that specific point and basically creating a whole list of what they call it crop patterns and how you are able to use this information for more innovation and interventions if it comes to a point that you have a crop failure. These three things alone, as it stands, are billion-dollar businesses in itself. A farm KYC, somebody like Airtel, Vodafone, Reliance Jio, they are already onto it. They are creating this information. A farm stack, which is basically location dimension, this has been Government of India, Ministry of Agriculture's job from the day they were established, and they're still continuing. Okay, crop stack is all your big baskets, all your big retail companies who are able to go back and see where they can source from. All three standing on its own is your big billion-dollar businesses all put together. How do you make them talk to each other seamlessly? This is the overall concept of what we call as the operating system for agriculture. Any questions? Sir, can you tell your name as well, please, and introduce yourself? Yeah.
Yeah, my name is Prashant Pai from TCS. When you say operating system, are you building a solution? Because why do you have to have an operating system? You'll build a solution on top of an operating system. So I'm not able to get why you have talking about operating system here.
Okay. Okay.
At a low level.
Fine. M-Kisan is your product only, right? Data consultancy service.
Yes.
Is that an application or is it an operating system kind of an approach for that?
That is not.
Okay, so M-Kisan is that part there, your farmer stack. You have all the data on M-Kisan, everything is good, but you're unfortunately unable to transfer that information back to, let's say, a farmer stack or to a crop stack. So the problem is every single company that is working on this is using one technology's framework on another and unable to talk to each other. Therefore, we need to have data brokerage. We have to have all that kind of jazz that goes in between. The concept here is eliminate all those so that you can have seamless exchange of information between that. Therefore, if you go back to the beginning of my presentation, it's either one layer OS that spans across the entire gamut of farmer, farm, and crop, or individual applications that work best in what it does. Okay, at the same time you're able to talk to each other. So therefore the thing of operating system, just remove the idea of OS as something that boots up in the middle of when you start something. Just remove that as a concept and look at it from the terms of interoperability. I will take you and I'll show you a video. In fact, Red Hat is one of the pioneers of this particular OS concept. About a couple of slides down the line, I will actually show that. Any questions?
Right now, we mostly talk about distributed computing and Hadoop and all. Is that somewhere similar to that approach? We are right now thinking of horizontal scaling, not the vertical. Are we going in that direction? When you need more instances, we add to that one. is it a distributed kind of a software?
The moment
operating
I show you two demos, you will understand that perspective, how you were horizontally scale based on the velocity data. So coming back, understanding your concept of Hadoop or any Apache Camel middleware kind of an approach, you are talking velocity, all the 7Fs, 7Vs and things like that, right? So here the thing with agriculture is you don't really need a lot of velocity. You do have velocity data, but you don't have a lot of volume data. You understood? So like just from the telecom perspective, if you come, it is just basically taking a gun into a nail fight. You really don't need these kind of data streams coming in. However, there is still use cases are there. I'll in fact show you two demos. The first demo is actually running on top of this building, on the rooftop of this building, and the second demo is one cow is waiting for us in Chennai, and I have actually tied him down there so that we can actually show you the accelerometer data coming in live from this place. So there you have your velocity problems. I'll take you through that in a separate instance. Right at the very end, I have actually put that as a point. So coming back here is the hardest part, so to speak, for agriculture has always been the absence of data. So anyone who has observed weather will be able to tell you that. Because have you heard of something called automated weather stations? Automated weather stations. Automated weather stations, there are many weather stations that are deployed around the country. Last count, it was 14,000 or something like that. Okay, that's a lot of weather stations that is reporting weather information left, right, and center. Go to IMD's website, look at the number of online weather stations. You'll see about 50% of them are offline. But primarily because they don't have that concept of quality of service or whatever it may be. So the thing is, you have massive chunks of data that is absent, right? So this is a key problem when it comes to crop insurance. Rain fell, my crop went. Sorry, boss, no rain because there is no evidence of rain. You're laughing. I think you face the same problem. My apologies. So what do you do?
I just retired as a deputy director, and now I am district director run by NGO.
Oh, okay. So you know exactly what I'm talking about, right? So the complete absence of that data is a key problem. Therefore, we have an issue of analytics. We have an issue of getting local sensing. We have an issue of putting that in public data sets. We have an issue of aggregation. How do you address these problems? These problems you're already addressing in the day-to-day businesses that you already do. How do you aggregate? How do you normalize? How do you bring provenance? How do you have 1 point, 2 point, 3 point failure? How do you address all these issues? How do you address multiple points of failure? Same concept, but the application of that is in agri. That's all. This is as simple as that. It's not as complicated as we all made it sound to be. But at the end of the day, you have all this. You are able to bring IoT data. You are able to bring local sensing data. You are able to bring public data sets. Suddenly, you have this very rich data set. This very rich data set that you can use, and you can run hundreds of applications. Anybody who knows Bhuvan here? I don't want any triple ITMK people raising their hands. Anybody knows Bhuvan here? You know Bhuvan. Sir, would you be able to tell the audience what Bhuvan is? So it's a website that is provided by Government of India, free of cost. Go and sign up. You will get every single weather satellite that India government has flown, every single remote sensing satellite India government has flown, water sensors, NDVI, DVI, evapotranspiration data, all these kind of data sets are already available free of cost. You can take that data, do a bit of remote sensing reading on the side, and you'll suddenly be able to come up and say, I can now predict what is going to be the problem of paddy in Palagat. I'll be able to say that plantain growing in this particular location has a problem of irrigation. This data set is freely available, by the way. Okay, today, if I'm not mistaken, in Times of India, I read an article. There is something called the India Data Observatory that they opened up. It's an open source data stream that is made available. You can go in, I think it is called, I keep on forgetting if I can find at the end of the presentation, I'll actually show you. If I can, it is basically all the data sets that are available in India that's freely made available to the public. That is replicating Bhuvan, by the way, on one part. And then has anybody used Earth Explorer from Google Earth? Earth Engine, not the Earth Explorer. Earth Engine, my mistake, Earth Engine. Okay, which is another remote sensing tool. They bring different satellites from all over the world, and they basically provide you all the indices that you require for creating very baseline applications, such as insurance, such as farm loan, such as understanding what is the health of all the open to sky crops. Horticulture not so much, but open to sky crops. These are the things that you yourself with a laptop can build it. Who was that boy who figured out where Krim lander went? Today, no, it happened. What did he do it with? He just sat at home and he just used some data and he figured it out. All your visual analysis, image monitoring, image processing data, this is basically what it is. Now, the key issue here, insofar as the agriculture system goes, you have three layers of problems and opportunities, as I would say. You have the crop, which is any crop could be there. Then there is the agro information, the generators and the consumers. So the generators are all these banking, non-banking financial institutions, NGOs, insurance, cooperatives, NBFSIs, FPOs, marketplace apps, who are all creating data on one part. And the consumers of that data is again governments, NBFSI, commodity markets, retailers, insurers, and input companies. Input companies are the people who sell you fertilizers, seeds, generators, pumps, all these kind of things. The problem is the data flow is completely out of whack, in the sense that from crop it might go to a marketplace app, and the marketplace app might connect to a cadastral data or a weather data, and you simply don't have what is called a structured data flow. Anybody who is working in this industry, coding, working with data, knows this problem. When you have multiple data coming, if you don't normalize it, if you do not transform it, that is going to create a problem for you. So what does AgriOs do? AgriOs tends to normalize and fix that data problem. So how that works is the following. Pretty straightforward. All the crops generators, we go on the sensor data right to the top. So you have satellite data, as you said, IoT, drone, crop phenology, cadastral data, statistics, machine learning, Hadoop, right at the edge, weather data, all those are integrated into one platform, computed and made available for you to go and query and create applications around it. Then sell that very same data across through consumers themselves. From the generators, consume the data, do the computation analysis, push it back to the from the generators, push it back to the consumers. So, for example, who else came from farming here? There was one more hand. Sir, you. So where are you from? Trivandrum. What do you do in terms of farming?
I'm doing homestead farming, basically hydroponic farming.
Hydroponic farming.
Yeah.
Have you done any farming where you have to go to Krishi Bhavan and get loans?
Which one?
Krishi Bhavan and get loans?
No.
But do you know of people who actually have to do this?
Yeah.
Okay, so how do you get loans? How do you get loans? So you go and you say, look, I want to put paddy. Okay, I have got 3 acres of land. I'll put paddy, and paddy has big interest in the government. The government will say, take loan. The thing is, if you don't give loan, that becomes a political problem. But this thing is that people have become smart, in the sense that now if you want to put paddy, you need to know, the people who are giving you the loan needs to know whether you have actually done paddy before. So that's where they go back to satellites. Satellites, they say, okay, 10 years worth of data is there. Please tell me in this location if this guy has put paddy, yes or no. So companies like Satshore, which is my other startup, they go and they say, okay, you know what, we have analyzed this. Yes, he has put paddy, but for 2 years, he has not put paddy, he has put plantain. So the bank is now to take a decision. Do I give this fellow loan or not? So that's completely a bank risk management process. So the bank will say, okay, you know what, I'll give him loan. So he comes, he takes the loan. Now what happens after that? What happens after that is, sometimes he does not put paddy. This is very prevalent in North India. You go, you take a crop loan. The next thing that you do is you buy a car or paint the house and things like that. It has happened. So now you have to monitor that loan. So your entire portfolio monitoring happens on one information stack where you are able to now see whether this guy took the loan, has actually bought the seeds, put the seed on the ground, the seed is growing, and things are coming out. Now the question now is, the next big one is, will this guy ever be able to pay it back? So how do you calculate? How do you figure that out? Sir, you're from the agriculture department. You will be able to tell the audience much better than I do. How do you figure out if this person will be able to pay back these loans? You go and look at what's called as the minimum support price. What is the minimum support price that has been provided for this particular crop the previous year? Therefore, you do a basic calculation. This is the productivity. This fellow is able to now pay the loan back. And this becomes your risk management. All that driven through that platform, that stack, which integrates different types of technology in one area, one DB, probably Hadoop or any of your MongoDBs, Cassandra, whatever it may be. Any business intelligence tool like Tableau or D3JS or whatever it is connects. You run a query and you'll be able to get the risk profile of this particular farmer. See how that changed? I can give you hundreds and hundreds and hundreds of examples. So,
our government is not following any structured process, because it's only political decisions. Even Mudra loan, that is collapsing down. So a lot of problems are there.
Correct.
But maybe your operating system may have some analytics, everything that may be useful. That's why I'm giving ear to you. Okay.
I might be contradicting myself when I say I do not believe in a technical solution to an administrative problem. I don't believe in that. However, technology exists to bring together and address certain parts of the problem. Certain parts of the problem. This is a good start. It's not bad. It's a good start, and people are getting it. So some of the banks right now, they are not giving loans without KYC. It's going to become a very big political issue in the coming few years, coming few months. So now you see how it works. You have a decision support system on the top that needs data coming from different sources. You bring all the data into one platform, one operating system, one application stack, and then provide that application stack, and then give this application stack as different decision support tools for at the Department of Agriculture, for example, at the bank, when to irrigate. It's a very important, water and irrigation. When I see that the land is going dry, that could be my point when I come and I irrigate. Is you don't need to have common sense. When you have lots of evapotranspiration, when you see that your things are drying out, you can now do better irrigation planning. When the crop is ready for harvest, classic problem in Kerala, Alapura. Crop is ready to be harvested, no harvesters. Oh, rain comes, my crop is gone, insurance payout. Now, using this kind of technology at very large scale, you're able to see and plan the harvesting process. Multiple use cases, dime the dozen. Now, I will take you to one particular video. Anybody heard of Red Hat? Red Hat. Red Hat has been bought by IBM. Okay, they are dying for use cases. Okay, this is something that they have come up with. Can somebody hear the audio on this one? Can we get audio on this?
The soil sensor is somewhere in this area. There are several at different levels, so we're really measuring temperature and moisture and conductivity throughout the soil profile. Agriculture has gone through many evolutions. The transformation in technology in the last decade has actually been driven by the high cost of technology and automation. We have the opportunity to flip the script and really drive the cost down so that the technology for a smallholder anywhere in the world is the same as a large holder in the Midwest. There's this tremendous potential for exchange. We can actually aggregate hundreds or thousands or millions of farms and data points and get our confidence that way. So much of our language around how we work with the environment is negative, when in fact, if we collaborate, we can draw greater insights. We can start to repair, restore, and regenerate our environment. My work at Wolfsmith Center for Agriculture and the Environment is usually to connect with the farm team and begin the process of human-centered design. How can we create tools that are going to help answer questions and make better decisions on a day-to-day basis? The observatory in the field, the groups of sensors that we have out there cover a wide range, more than 80 different indicators. We have air quality sensors that EPA has installed. We're measuring the total energy that's hitting here with the instrumentation from the USDA Climate Hub. We have a lot of co-deployment with open source communities using low-cost data loggers and sensors alongside some of the industry standard equipment. The data that's being collected is being aggregated by our partners, but we're also pulling that into FarmOS. This is Wolfsmith here. We can zoom in and look at the history of what happened at any field. FarmOS is an open source platform for agricultural management and record keeping, collecting all of the different types of observations on a farm. Animals, plantings, equipment. Because the FarmOS creates a common way of organizing agricultural data, we can then aggregate a single farm with another farm regardless of production system. We're collecting our own soils information, but we can also connect in with the USDA soil survey and their map and overlay those results. Our ability to communicate our best knowledge to anybody on Earth gives me great hope and optimism. The power of open source is what makes a lot of this possible.
Me why Red Hat of all the people is interested in farming. Red Hat, they are an enterprise play. They are into servers. Huh? What will Red Hat do with data? That's not their primary business, is it?
Food and water are the most
Important commodity. I think in the future, food and water will be the most sought after commodity. That may be the reason in future.
Okay. Any further comments on why Red Hat would be interested in farming?
With the e-commerce sites, like I think the Walmart has been taken some data to get the crops from the particular area directly. For that they can use this data, so it will be come to the next phase of business maybe.
Okay, cool. Somebody else had an yes, sir.
Maybe they are targeting towards an industry where the buying potential is low. I mean, in terms of expenses, they can provide low-cost solutions which can be widely adopted because they are open source and they are leveraging the power of open source.
No, they are not open source. They claim they are open source, but they are as closed as the dollars that you pay them. But you have a very valid point. The point is, you're talking millions of devices. You're talking millions of weather stations. You're talking millions of IoT devices. You're going to swarm a lot of these things. And where does Red Hat want to be? They want to be the OS. Ubuntu, very recently, I'm sure you guys would be reading Ubuntu. What did Ubuntu say a month and a half back? Ubuntu had come up with a very interesting article. One of the key, researchers at Ubuntu said something that was just totally counterintuitive to what is happening right now. Has anyone read that article? Okay, just you may want to Google it. Ubuntu said the future is not in the cloud, it's in the edge. So now I have 1000 IoT sensors, I have 1000 automated weather stations, I have 1000 soil sensors, how much is it now? 4,000. 4,000 sensors that I have to place, and suddenly I need to have an operating system that synchronizes the whole lot. Suddenly I need to have a middleware that synchronizes a whole lot. Now I need to normalize the data. Now I need to bring in all the data systems. I need to ensure that I don't have data loss. I need to provide quality of service. I need to do all this. That's the reason why Red Hat, of all the people in the world, moved in that direction. I wonder why Ubuntu has not done that so far. Probably they have. In Raspberry Pi, I think they have done a lot of good work, right? Even Microsoft is going there. Google is already there. But FarmBeats is an OS? It's not. It's a type of data. Okay, fine. So you have all this big boys playing into this field because they know for a fact that they'll be able to sell their core technology, which they have developed over many years, investing billions and billions of dollars into it. And suddenly somebody comes with a Raspberry Pi and then upturns the whole thing. Now I can run an automated weather station out of a Raspberry Pi. In fact, that's exactly what I'm going to show you in the next couple of slides. So the advantage that we have right now, look at it. Just put this image in your mind when you think of AgriOs. You have all the agtech companies, the Syngentas, the Monsantos, the Mahindra and Mahindras, John Deere's. Who else, sir? There are many. I mean, I keep on forgetting. Sir, a couple of more agriculture companies, sir, who are in a lot of companies, okay, who are in this space. Then now and then suddenly I have IoT devices. I have automated weather stations. I have soil sensors. I have pump, actuators. I have hydroponics. Okay. I have blockchain infrastructure, provenance. Everybody would ask, why agri and blockchain? That's provenance. It's all about insurance. It's all about understanding exactly what has been the output in my field and how I'm able to convince someone that rain actually fell and I lost my crop. Provenance. Data science. I mean, bringing all this data, normalizing it, aggregating it, producing actionable decision support systems for banks to lend, for Mahindra and Mahindra to send more pumps. Network security. I have IoT devices. Suddenly, I create 1000 endpoints that I have to look after for security. How many people work on IoTs here? You work on IoT. You work on IoT. Sir, can you just give one line, one sentence, probably 30 seconds to explain why network security is important for IoT devices?
Very basic is for the data security, data capture.
Correct. Data capture. So now automated weather station says it rained, somebody hacks in and says it did not rain. Suddenly you have a problem. So now you have data security, synchronization, geospatial services. Satellites are being sent up. You know, we have to look down and we have to generate more value out of that information. Drone analytics. Companies are dying the dozen, putting much higher payloads into drones to do point cloud, to do road mapping, to do paddy analytics, to do coconut analytics, you name it. I mean, it just keeps on going. Mobile apps. An app will all... I have this problem with apps always. The problem with apps is everybody thinks a mobile app will solve somebody's problem. I mean, it's just not. You have a problem, you create an app, suddenly it goes away. You know, it happened in agriculture a lot. You go out there are hundreds and hundreds of apps that are there who are trying to solve one small problem here, one small problem there, but not an integrated approach. However, when it comes to financial inclusion, when it comes to wallets, this is very important. Now I have a system where I can now process the entire claim without even the farmer coming anywhere closer to me to come and submit a document which says that my crop is gone. I'll take a picture, it gets uploaded, AI is used for analyzing that, weather data is looked at For provenance, satellite data is looked at provenance, and all that thing comes across, and now suddenly you are able to determine how much payout needs to be provided, and that can be credited onto a payment wallet. See how the landscape changed? And we're talking agriculture. We're not talking about buying things in Amazon. This is the landscape. This is the future. This is the basis of building, or the argument in support of having an integrated operating system that goes across all the platforms. Do you want me to break now? 6 o'clock? Okay. So I'll just take you to the Raspberry Pi demo. Right, the use case, weather. So what is the local weather today? Anybody knows? Huh? Not raining. Why? I thought it was raining in the afternoon. Huh? Okay, I will just click on this and see if it works. Yeah, it works. Oh. I have to bring this to, yeah, right. Does anyone know what is called icy FOSS? Sir, you nodded your head. What is icy FOSS? I'm sorry I'm putting you on the spot, but you said you nodded first. Yeah. Where do you know where they used to be? 7th floor. Yeah. They, correct. Okay. So what they did while they were in this building is they thankfully made a nice little weather station and they put it on the roof of this building. This data is actually live coming from that weather station. It is complete homebrew. Huh? This complete homebrew, Raspberry Pi with power all hooked up, and sometimes the data goes off, sometimes the data comes back in. It also actually shows the humidity and temperature of the Technopark front gate, and humidity and temperature is Tejaswini. We were having this argument why it is low here and high here. I mean, I don't know. I mean, I'm not going to answer the question, but why is this important? Why this is important is because this was just an open source community, two people sitting across a table, pulling some boards together, putting some wires together, building this, deploying it on top. And now this actual data is consumed by some of the weather companies. Now imagine I am hoping that you are all good in coding, and I guess you guys can also tinker around with some application stack. Imagine buying a Raspberry Pi. Imagine buying a small, what you call a temperature sensor. Imagine buying a small humidity sensor, putting it all in an IP65 rated casing, put it on top of your building, connect a Geo SIM card to it, and now you have your own weather stations reporting granular weather. If you can do it, he can do it. If he can do it, sir, you can do it. If you can do it, sir, you can do it. Technopark, there are 100,000 people. That's 100,000 sensors. Anybody who has done big data systems talk about velocity and volume? Sir, you were there, no? How do you manage 100,000 sensors reporting back information to you on a minute-on-minute basis? Over the cloud. Interesting. Okay, fine, over the cloud. But this is not done over the cloud. The last mile here is done over the internet. But this is communicated through something called the LoRaWAN protocol. Have you heard of a LoRaWAN protocol? Yes, sir. You have nodded your head. Please explain to the team, to everybody here. Yes, but there is one key differentiator. What is the differentiator there? Okay. There is one more. There is one. That's very good. Why is the bandwidth low? Absolutely. FAYA.79. When was the session? Last week, is it? Last month. Okay. So this entire thing is built over a LoRa sensor, which costs 140 rupees. Those sensors are a different cost. I'm just talking about the communication protocol. Carbon dioxide sensor, methane sensor, and all these are additional costs. But if I'm not mistaken, this entire thing stack would cost them about something close to 2,000, 3,000 rupees, not more than that. Arduino, we are talking about a small board. So yeah, 250 rupees. You can just go to Tagaraparam Road and pick all this up. Imagine building this and deploying it in the millions. And this information is also very important because, sir, I was saying that it rained. You said it did not rain. You said it rained somewhere else. See, three people, same room, three different opinions on the weather. Now imagine trying to quantify all this and taking to a government organization that please pay me money based on this information. So you need to have all this kind of what I call it data, what I call it provenance, the data quality, the data assurance in order to take this. It is not going. It's not a magic bullet approach. It will take time, but we will have to start somewhere. So we as MistEO, we have taken the first step. We are actually building some of the weather sensors. In fact, we hopefully will do a project in Palghat about for 7 reference units. Same concept. We are putting weather sensors to just to test. I will get you that information. I just got that today. So 7 reference units we are doing just to check out if paddy is working or not. This is basically the concept behind it. So this is very important to that. Before we go to the next demo, I think we've got about 2 minutes to the what you call it to the break. I think we'll take a break because I will set up the next demo, and I believe coffee and tea is served. So yeah, it's right there. So we'll get back at what time? 5 minutes? Okay, in 5 minutes. Tea and coffee is served. Hello. Yeah. Hi. So yeah, again. Coming back from the break, um, everybody has heard of IoT. Everybody knows what IoT is, but has anyone heard of Internet of Animals? Deepu is laughing. Has anyone heard of what is Internet of Animals? Tigers, yes. Then, perfect. Then, cow is there. So yeah, I kind of gave away the game, didn't I? So I thought I'll do this because it's much more of a mature use case that we've been working on for almost 2 years now. It'll be interesting to show you how the entire thing looks. So the idea behind Internet of Animals, why we went down that path, is because if you take agriculture as a whole, 40% of that is animal husbandry. The rest 60% is your crops and everything. There's a huge number of what they call it. There's a lot of opportunity in that area which is completely unaddressed. So you're a typical veterinarian, that kind of rearing cows, milk, farm animals, economic value of the animals, that kind of stuff. I believe only in Kerala we've had this decline, but everywhere else farm animals are strong. There's a lot of people who are keeping tamed cows and other economic animals in their houses and their farms, and we thought this would be a very interesting thing to address. To the last count, 625 million heads of cattle exist in India. 625 million heads of cattle. That includes goats, that includes sheep, that includes cows, that includes buffaloes, that includes, who are the other domesticated animals? Dogs, no, I'll keep that aside. Cattle, okay? So you have all this as an opportunity right there, and we went ahead and we built a nice little cow tracker. And we were laughed out of the room when we initially proposed this multiple times. Our friend Deepu here is also guilty of that. Okay, and but we persisted, and we kind of now have a prototype that is working. And in fact, this is a very good example of how an IoT device works remotely and what you could do with that. So I'll just show you what the entire concept is behind this, and again we'll go and dive deep into some of the technology part. So the idea behind that, again, if you go back to my original slide, aggregation, normalizing, analysis, and that kind of stuff, you have your communication platforms, which is your LoRa, you have your NB-IoT. How many people know here about narrowband IoT? NB-IoT devices? Anyone? Okay, NB-IoT is a new protocol that is coming up, and basically this is going to be the lifeline of smart cities as smart cities if they ever come in India. Okay, that's on one. I think Reliance Jio, I think, is the only company that is doing that right now, and then of course now Bluetooth 5, which is a new protocol of Bluetooth which exists. So we have basically used these three communication platforms to do the following: to create what we call as a pattern recognition, anomaly detection, recommendation engine, data ingestion, and data storage. And the outcomes of that is look at the health, anomaly detection, feed intake and rumination, heat maps, identifying unproductive animals, fertility management, feeding and rumination cycle. Okay. This is basically the outcomes of the data that we collect on these animal devices. So how is it structured? Essentially, what you end up having is the consumers on top, the dairy cooperative societies, the fodder cultivators, veterinarians, animal husbandry people, banking and institutions, protein and export business on one part. Then you have weather stations and you have satellite data on fodder and veterinary records, basically driving what is called as an animal welfare perspective, which is pretty new, that is coming to India. We have never actually even thought of animal welfare. There is, of course, animal welfare officers and things like that, but a data-driven approach kind of did not take off because I think it was too much siloed in terms of information. Now, the idea is that we can bring it all together because we have big data platforms. We have IoT devices on animals called Internet of Animals, and then we can basically collect all this data and provide that as information to the key decision makers. So what we ended up doing, again, this is core tech, nothing to do with what you call it, industry related stuff. We have the detector, which is a small GPU, sorry, a small microcontroller unit, and the conventional approach was to push all the data to the central core. Instead, what we did, we said we will take data, we'll take the processing to the edge. We created a nice little edge compute device. We created a nice little low profile MLAI code that is running on the edge. We basically did the classification on the edge, nothing to the core. We are not bringing back anything to the core. Everything is done on the edge. And what we did, on top of all that, all these things, push it over LoRaWAN. So now I'm able to save power. I'm able to run all the edge devices as I want. I can swarm millions and millions of cows who wears these devices, and I'm able to gather all that information, and I'm able to give that as a dashboard to veterinarian, to a bank officer, to the farmer themselves, to what you call it, fodder manufacturers, feed manufacturers, whatever it may be. This is just picking up right now. And now we will get on to the demo part. Now I will switch on to Google Hangouts where my colleague Vignesh is waiting to show this. Vignesh, would you be kind enough to share your screen? Right. So, beg your pardon? It's completely automated. So it's basically a 3-axis accelerometer data. So what you see, this data that you see here is coming live from our animal in Chennai. So this is basically 1820, 1810, which is approximately right now. Okay. It's a three-axis accelerometer. So you have the x-axis, y-axis, and z-axis. What we were able to do is we were able to identify the different key points. We were able to write an ML code, and we were able to say that this animal is doing this right now. So it means it is ruminating. Ruminating means after it fed, it took it inside, then it has brought it back up, it regurgitated it, and it's chewing that. So that's ruminating. Feeding has a different, take on this. Drinking water is a different take on this. We have a GPS device attached to this. So I'm able to geofence the animal and say, if this animal is going in this direction, please alert me. It's going in this direction. See the potential. It is just a device that's sitting on the neck of a cow. And this is coming from Chennai. I mean, we are in Trivandrum. All over LoRaWAN. I can take this to a bank who is sitting in Mumbai, who is having a loan book of 5 million cattle. I can take it to somebody like who are the big manufacturers, the milk producers, not Milma, somebody else who owns the assets. Amul, no, they're a cooperative, no? Do they own animals? I think they do, right? They do. Mother Dairy, Arvin, places like this where we are able to now go and say that this is the health of your animal. And the most important part, why do we do all this? Because, have you heard something called the heat index? 2 heat indexes are there. There is a heat index of productivity, which is basically temperature, humidity on one side. Vignesh, would you be able to just show the temperature, humidity part? That's an actual device. That's the actual temperature coming from the cow shed right now. And we are able to figure out what is the stress of the cow, whether it is stressed or not stressed. So there is something called the THI. The THI is an index where you look at temperature and you look at humidity and gives a cumulative score. If the cumulative score is above stress, that means that you have a decline in productivity. Imagine I be able to swarm, let's say, a whole, what do you call it, cattle shed full of cows, and say that, look, I have no stress in that area. Now I can go to the vet and say, look, this is my the performance of my herd. Now you please give me what do you call it, a better feed mix. Or I have stress. I basically take and I go and I fit sprinkler systems, air conditioning. I don't know. Did anyone see the VR for the cow? It was going around for some time. Some Russian prank was there, no? They had put a VR device on a cow, entertaining the cow, playing jazz music. I don't know. I mean, you could do hundreds and hundreds of things. So this is just data that is coming from which we can use, and all because we are able to bring IoT data using a very low end power profile equipment, both network side as well as edge side, streamed using Kafka into an AWS stack, then pushing the data back into my local computer sitting in Chennai, streaming it live on Google Hangouts. This was not possible 5 years ago. So what do you need for this? Yeah, kind of, but 5 years down the line, I hope that we could say the same thing. Okay, but 5 years ago, the same problem existed. So at that point in time, we were not able to show, but the technology also did exist at that point in time. That's what I'm trying to say. The technology for IoT, swarming, I mean, how many people have learned Apache Spark 5 years ago? Yeah, it was around for ages. Camel, middleware, all these things existed 5 years ago. Well, it existed even before that. Telecom industry, this was standard. So now we are able to do all this. So the question now is, we need to ask, as technologists that we sit here, when you look at use cases, how you are able to view the end product, create the platform, create the operating system, pardon my interpretation of operating system, create the operating system in such a way that is just plug and play. I open a device, switch it on, just like the iPhone. See the possibilities? Vignesh, you may shut it down. Thank you so much for your time. That's Vignesh, who's sitting in Chennai. I'll continue with my presentation. I explained all this to you, which is basically what is going to be, who is the value added, who is the value player in this, what are the things that we could do, how is the entire system being commissioned, what are the key actors in that system, how you bring all that value to the customers who are right at the bottom. I explained this in another way to you guys, but I would like you to take you to this slide. So this would be an ultimate dream. This would be an ultimate dream where I have very low cost network nodes sitting in the field, sitting on points in earth. I have very low cost devices that is connected to AWS stations, to animals, to soil sensors, to irrigation monitors, to hydroponics, to soil nutrient sensors, to God knows CCTV camera that is monitoring crops. Okay? Integrate all that through a network, bring it back to a central core where all the data is processed, the data is normalized, and then it is provided for application type development right across the board. This is an integrated use case. This core, to make this happen, we need to have the AgriOs. With that, I thank you for your time. And I believe I am well within time. I am now open for questions. One slide I forgot. I'm back. So, what is the future? The future is edge. The future is lightweight machine learning and AI. The future is optimum power. The future is big data. The future is network. And the future is provenance. Blockchain, network, big data tools, optimum power organization, ML AI, and edge compute. This is what the future is holding. 2024, this will be reality. With that, I again thank you for your time. I'm open for questions. Technical. So do you want to know what we really did there on site? Yeah, there is. So what we really did there was we had 5 cows. We created all these devices. We had 5 CCTV cameras installed all over the shed, and we started streaming all this data and the accelerometer data into an annotation engine. And the annotation engine was basically, the timing was synchronized. So whenever there was a motion, that particular frame was grabbed. Manually, we annotated it for almost 2 months, and then we wrote a code, and then it started annotating it automatically. Our sample size for 2 months worth of data was something close to 1 billion data points for 5 cows of 1 billion data points. That was just 2 months of data analysis. From that data analysis, we were able to extract 5,000 classes. From that 5,000 classes, we were able to extract something about 2,500 features. And I'm going to discount 50% of that because most of them is useless. The cow is looking this way, that's looking that way. Those things go off. And 50% of that data we were able to use, and we created 4 outcomes: rumination, feeding, standing, sitting. These are the 4 things that we actually came out. We had to use a lot of local knowledge as well, because the owner of the cow used to tell us, this is how it behaves, this is how it behaves. Now the model is optimized in such a way that we can run that entire thing over an ML code, and basically I can now take it to different geographies. And that's where the biggest screw up happened, because if I change the breed, all my data goes for a toss. So I have to start again. So by then I had already figured out how it needs to be done. We are doing that again. Yeah, we went to the indigenous cow people. They laughed us out of the door, sir, because they said these things never fall sick. So, we are trying. We have not yet reached there, no. So, because statistics. Sir, I won't be able to answer that question. I will connect you to my colleague Vignesh, who is actually working on it. He will be able to answer that. I will give you my card. Please write to me, and he will be able to do that. But what I do know is that it is a very lightweight ML model that is running in the edge. But the statistical model behind it, I am not exposed to that. I'm sorry, I won't be able to answer that question. Sir. Yes, sir.
Everything works well, and how do we deal with the problem of plenty? How do we deal with the problem of plenty? Because we say that 2 million people are there, 2 billion are there in India, and then probably another 3 billion will be there, 4 billion will be there, and there. So the food that we produce will be, let us say, twice what it can be consumed by the people. And maybe all the other things that we do will be maybe 100% to 200% excess. What do we do? Because everything is dependent on supply and demand, and then what will happen?
What was the conversation we had today? Today we had buttermilk and I had onion in it, and suddenly I was a very rich man. I mean, the problem of plenty always existed, sir. There is no question that it is going to go away. We are wasting 50% of all the food that we make, plus 50% of all the food that we make. The idea is not so much to address the problem of plenty. The idea is to remove inefficiencies in the system. The problem of plenty is a policy related it's a policy related matter. Practically, it is not going to, none of this technology is going to address that problem. Unless otherwise we were to say, okay, we figure out a way to protect and save the food. So there are many companies who are actually working in this domain. If I'm not mistaken, one of the people that I know, the problem of plenty problem, what they solve is this brilliant idea they've got. Does anyone know black soldier fly? Black soldier fly. Dr. Nitin, you know black soldier fly very well. Has anybody heard of black soldier fly? So this is a small larva. So it's a small black, it looks black, and that's the reason why it is called black soldier fly. You know what it does? It eats food, it eats waste, and it converts waste into good protein. So the larva, it goes around, you put it in a chamber, it'll go and it'll put thousands and thousands of eggs. All these eggs will hatch, larva will come out and it just consume all the food. The larva will become big. Then what you do is you basically steam boil it, okay, or feed it like that to chickens or pigs or whatever it is. So this way, this person that I know, he manages about 8 tons of food waste a day in Cochin, and that's because he's got a plant of 1 ton. He runs it 24/7. He's got like this plant of 1 ton. Each ton reduces that food to about 300 kilograms, and that 300 kilograms is weighing about what? 21 rupees a kilo. This is your protein that is gone and you're sold. So there are multiple ways of dealing with this question of plenty. Equitable distribution of food is a policy problem which has to be addressed at a very high level, because we heard that problem yesterday of somebody starving and eating മണ്ണ് നിന്നു എന്നൊക്കെ പറഞ്ഞ വലിയ പ്രശ്നം ഉണ്ടായല്ലോ. അതെന്ന് പറയുന്നത് ഒരു പൊളിറ്റിക്കൽ ഇക്വിറ്റബിൾ പ്രോബ്ലമാണ്. അതിന് ഫുഡ് പ്രൊഡ്യൂസ് ചെയ്യുന്നോണ്ട് അതിന് ഇത് വരുന്നില്ല.
I was not talking about that in terms of that, but the economy on which it is actually based on, it will crumble. That's what I said.
Not really though. We have seen that it's almost self-correcting most of the time. We've had multiple onion scares and multiple tomato scares. We still consume onion, we still consume tomato. So the system kind of takes care of itself. I would approach it from a different angle. My angle would be removing the inefficiencies, making sure that the farmer gets a fair wage. This is what I would be addressing. And then I would be addressing the nutritional point. I'll be addressing the nutritional problem, giving them the right nutrition. These are the two things that I would address using tech. That's the answer to your question. It's anyway too complex for me to answer with my limited knowledge of how the problem of plenty has to be sorted. Any further questions?
What's the benefit the farmer gets from this data points?
Beg your pardon, sir?
What's the benefit the farmer exactly gets from the data points?
So you want to go back to the example of the cow, or you want to go back to the example of the weather?
No, just like the example.
Exactly. Okay. Do you remember I said something called the heat index, the THI? So there are two heat indexes. The one is where the productivity is a problem. Productivity drops, and the other is productivity loss happens. Productivity loss is when you miss the estrus window. Estrus window is the time when you have to artificially inseminate a cow so that the productivity of milk continues. If you miss that window, that's 21 days of loss of production. And it's a 24-hour cycle. Typically, it happens middle of the night. So the idea is that you look at data models to predict the estrus window opening up between point A and point B, which is a point D-1 and D+1, and accurately predicting that this is the window where you have to inseminate the cow. This, if you lose 1 liter of productivity a day, it is 40,000 crores productivity loss a day. I think that's only Kerala, right? If I'm not mistaken. Something around that. That's the ridiculous figure that we are talking about. 1 liter. Imagine one cow going offline. Sorry, that's I have no other way to put it, but imagine one cow not being productive. So this is the advantage that they get. So this accurate window ensures that there is income that will come to the farmer at the later date. Likewise, mastitis, for example, which is another disease which hits a cow. 20,000, 30,000 rupees just gone treating it. So we are able to predict this, the onset of mastitis. That itself is a huge boost to the farmer because you can reduce the losses that the particular farmer faces. So, the AgriOs, as we say, is the infrastructure, so to speak. So the infrastructure will enable the data transfers to happen on time. So the data that comes from the sensors that goes to the analytics that then produces the results are done in near real time, or with what it's not, provenance is not the right word for it. I think it's, what's the word for it? Timely. Yeah. What's the other? I don't know what the other word for timely, but timely interventions can be provided. Irrigation is the best case example. I mean, planting. It's a very good example where if we are able to look at the irrigation window and we are able to trigger the pumps at the right time, you save a lot of cost. At the same time, you make sure that the crop loss is prevented. Okay. Yeah. Yeah, but as we said, every crop is different. So yeah, so it's a very common, that's a very common practice. But you go to Maharashtra, the place where it gets all the rain, still it is irrigation is a problem. So that's where it's ironic to say that you need to have climate resistant cropping in Maharashtra. Come on.
That is more crop per drop. That is a private
More crop per crop.
So that the efficiency matters.
Yeah, but is it efficient? That's my question. It's a big problem that one person can't address it. One company can't address it. Onion is the great example. I'll come back to onion. Many years ago, tomato was the culprit. Every tomato prices went up, everybody went into tomato. This year, onion went up, everybody's going, I'm going to give you, I will probably bet you 100 rupees on 1 kilogram of onion, that next year the onion prices will tank at the same time, because suddenly everybody is getting productivity in onion. We'll all go put onion crop. On the other hand, ginger was a problem. What was the big issue of ginger? To a kilogram, you know how much it was? About a month and a half back, 300 rupees, ginger. That was why? Because we had unseasonal rains. So these are the kind of stuff that, totally unrelated stuff, we are able to now bring it into one platform and then provide that kind of information. This is the overarching agenda behind having that integrated platform. Any further questions? So
Internet of animals, you said, no? So making that device, will that not be a complicated one? Like even
absolutely. It was extremely complicated. We took about 2.5 years to get to that point. It was not a 1 month job. There were multiple trial and errors, multiple places where people stole some of our ideas. So we had to so there were many issues. But right now where we are, it's a good place, because we have kind of nailed it in terms of what exactly the industry needs, but primarily looking at from the animal welfare perspective. So again, user, focus, application, build, development, deployment. This is what it is. It should not take, if you are going to get into Internet of Animals, let's say tomorrow, it should not take you 2.5 years to get to that point, which we struggled. It should take you probably a couple of months, because we have struggled. We know exactly what are the things that you require. Again, bringing back the OS environment. Put all the blocks and pieces in the right place so that you are then further enabled to, do faster prototypes and things like that. ICFOS is doing a great job. You should go and take a look what they have done there. They have done a brilliant work there, where all these concepts that we are talking about, they're actually putting it into practice. Deepu can help you with that. Questions? Yes, sir.
Great question. Like,
you're keeping them from dinner, you know that.
Actually,
See, can this be used by manufacturers to make a system so that cultivation could be done automatically with their help? Like years back, I worked on a combined harvester. So the thing is, just before flooding, they get the order, and when they get in, everything's gone, and the productivity is all gone, and they have to pay for the harvester as well. So, can we envision a system where farmers just have to sow everything, and they'll come in and they'll do everything for them, like a
Farming
service.
as a service.
Yeah, see.
Mahindra and Mahindra is doing it. Kirloskar is doing it. Any contract farmer does this. So that business model exists. That business model exists. All you do is you provide the inputs and you provide actually the seed and the fertilizers and an irrigation schedule, and that's it. Thank you. The rest of the thing is done by them. But it's a good idea. I think we should explore that in Kerala. I think we should do it. So I guess we can wind up the session now. So thank you once again. I hope this session was instructive and I was able to give some ideas. I'm sorry this is not your core technical, which port needs to open to get streaming data. But what I wanted to do was to come and talk to you about what I have observed elsewhere in the country where people are making leaps and bounds. Here we are sitting in Technopark, 100,000 people with a lot of core technology expertise. It's about time that we step up to the game, and it's about time it from a different perspective. We have all the key skill sets here. It's just a matter of bringing it together. So thank you once again. You can reach me on samuel@misteo.co, and or you can go to our website www.misteo.co. Sir, you can reach me on the email. I'll connect you to Vignesh, and he'll help you with that. So thank you once again, and thank you, Deepu. Thank you to the FAYA team for hosting me. Have a good evening.
Thank you, Samuel. Thank you for your valuable time. Now let's welcome Deepu to hand over the certificate to Samuel.
Thank you, sir. And actually, Fireboard normally have always technology sessions. Like earlier, whenever we want to do something on agri plus technology, it was an experiment. I also telling him like whenever we go to our audience, everyone will be expecting something on JavaScript or React or those type of things because it is how the past 6 years we have. That is the type of expectation that we have. I'm so happy to see all this much people here together who are looking for agri and agro and industry technology. And Fireboard is always bringing like-minded people together in one so that you can get to know each other. Yeah, I think that didn't happen to lead this community and those who want to be part of that. So how to start? Normally, we had a lot of WhatsApp group and all this. We are tired of that. But if you want to start with a WhatsApp group, that should be fine. But we will normally get to a meetup and then conduct events. But for initial communication and coordination, like you get it. And after the session, if you want to be part of it, then you will stay back and get you. And we have Philip Jones here. He was like long before when we talk about the history of FAYA board 80, 13 we started it. Before that, he was the one who gave the spark of having a community like this. And I think you are coming here for the first time, right? Sir? Yes. Yeah. So it is just like at a GTech meeting, like he was telling, like, why couldn't we form a community like this for people of passion come together and share knowledge for free? And actually, unfortunately, it didn't happen at that time, and then we thought of doing it together. So, DJ sir is here. I want listen to.
Thank you, Deepu. Thank you, Sima. I was there in for quite a long time ago. 1996. Then I started to work on this technology. So I am coming back again to many of them work through the GTech forum. We had a good forum for GTech for companies. I know Deepu. This session was very good. In fact, I worked on some but I was in CDAC earlier. I worked on a thing called agritech, like spurred systems. Long time ago, probably 1990. The technology was very immature at that time to start anything. But just worked on a little bit of thing called agritech, agriculture system. Just based on some information that we got from the agriculture university. That's why I got interested in that. Long time ago. Rejuvenating that interest and then gave me this session. Thank you very much. Yeah, it was very useful. Thank you.
So I asked PJ sir to hand over the. Okay. And if is there anyone else who want to even because I want to just want to give an introduction of that would be great. Maybe it is a time consuming process. Okay? I was a debut guy from my leadership and I have now I am working as a banana center. And fortunately or not, I started working market. I am immersed in that. I don't have time for agriculture, but still there are people from other states, Tamil Nadu. They believe me because of my capability as a horticulturist. I have a horticulture. I have a lot of experience. Especially one of my relatives also working in this artificial intelligence that field. Even listen, I have tried some. I am not a computer man, but right from '96 onwards, I started that program. Just for fancy, nothing else. Even I purchased some soil moisture sensors from Amazon, and I prepared my own program. I got this sort of graphs as this because the coding is available in Google. Everything is simple. That's he said. Take this opportunity to appreciate this man because he has done very good work. He brought out the OS. So we are expecting a get outcome out of that. I do not know if we are going to adopt this thing or not. That's